Class, so let me take your attendance. Okay. Iman here? Iman? Iman not here. Okay. Yichin? Yichin? Yichin not here. Forrester?
Yes.
Good. Wimi?
Yes.
Good. Iza?
Yes.
Good. Aris?
Yes.
Okay, good. Chike? Chike?
Yeah.
Good. Praveen?
Yes.
Good. Marwan?
Yes.
Good. Shinho?
Yes. Yes.
Good. John?
Yes.
Good. John?
Yes.
Good. Kevin?
Yes, here.
Okay, good. Yeah, so another two is missing here. I think,
Sir.
I don't know, Iman. Yeah.
Ethan.
Ishin, yeah.
Yeah.
Good. So I think only Iman. Last time we got a problem joining. Okay, so let me check on him. Okay, let me ask to join. Okay, so let's be continue for today's class. Today's class is very important. Today's class is whatever you learned last time in work energy power, and it's together. So let me start sharing your PowerPoint. Okay, so all of you can see the PowerPoint. Oh, sorry. Okay, let me check. Full screen. Okay, so today we're going to talk about motion up a ramp. A car moving up in an incline, going up. We done this question, but not in depth about inclined surface. So after this part, any inclined surface question, I think you can easily solve after today's class lah. I hope you understand clearly. Okay, so look at this picture here. Car is moving up. First, let's analyze in terms of force first. What are the force acting on the car? First force, this is the inclined surface. The first force is, of course, the weight acting down. But the weight we can resolve into its two components, W cos theta, which is vertically normal to the surface area. And another one is the W sine theta, which is along the surface area. Okay, then we have one force acting up, which is very, very low profile. What's the name of that force? Is the normal force. The normal force is always acting upwards, perpendicular to the surface, and the normal force is same as W cos theta. Right, same as W cos theta. Okay. Then, of course, you have friction probability. You have friction acting down if the car is moving up. And finally, the car thrust. Okay, now, let's say the car moving up because of the thrust acted, moving up. Can you write what equals to MA for this car? Whatever force acting up minus whatever force acting down should be MA, right? So therefore, based on force, the equation should be, in terms of force, should be thrust acting up, okay, thrust acting up, okay, sorry, pen, laser pointer, why the other foot doesn't work. Okay, so thrust acting up, and the thrust minus force down. Force down is what? W sine theta minus friction is equals to MA. This is in terms of force. Force up minus force down is MA, acceleration of the system. M is the mass of the car. Okay. So you can write this equation in terms of energy. We go slowly with energy. Look carefully. If you put it in terms of energy, okay, put it in terms of energy. Sorry. Oops, something wrong. Let me check. Okay. So in terms of cost, in terms of energy, if you want to be in terms of energy, all the forces here is just multiplied by the displacement. Okay, which displacement? The displacement, it goes up. Okay, displacement goes up. Let's say it goes up with a distance of s, a distance of s. So work done by the thrust is thrust times s. The s is what? S is the distance travel along the plane up, going up. Imagine the car is moving up with s. So work done by the thrust is thrust times s. Work done against weight is times s. Work done against friction is friction times s, and MAS, this is the net force times s. Okay, just multiply both sides with s. This is in terms of energy. Okay. Okay, so remember we rearrange back. So thrust times s, the W sine theta and friction, you put it the other side. The equation is going to be like this. So there is an important thing you have to clarify here. You see, whatever work done by the thrust, okay, let's say the car engine line in this case, the work done by the engine, which is the input, is equals to whatever work done by the engine tend to be what type of energy towards the end. It causes what? It changed to potential energy. This is actually potential energy. W sine theta s is actually potential energy. The friction times s is what? Friction times s. What type of energy it is? Work done against friction as another name, heat. Heat is what? Work done against friction. Friction times s is a heat. Okay. And the third, MAS, acceleration going to rise the kinetic energy. Actually, MAS is the gain in kinetic energy. So whatever work done by the thrust, is equals to gain in potential, W sine theta s, gain in kinetic, MAS, and heat, friction times s. It is the like a universal law, you have to remember. So go up again. Okay, so you see in this diagram, H over S is sine theta. Okay, H over S is sine theta. What is H over S? Okay, this is your H. This is your H. The vertical height is H. Vertical height is H. What is S? S is the distance you travel along the surface. This is S. Let's say the car starts from the beginning of the ramp going up. So this is your S. How S and H related is if this is theta, this is a theta. So H over S should be sine theta. Okay, H over S must be sine theta. Okay. It's got an issue here. Okay. Sorry. So H over S. So what we're going to do? So H is S times S sine theta. So remember the W sine theta, the S, right? The S, W sine theta, the S sine theta, we can replace with H. S sine theta, the S sine theta is H. Weight is what? Mg. You see, the potential energy is appearing. Mgh. So work done against weight is actually gain in potential energy, Mgh. It's Mgh. So just replacing the vertical height with the S. S is the displacement distance along the inclined surface. So work done against gravity is stored as GPE. The W sine theta S actually stored as GPE to the car. Okay, friction times S, work done against friction is dissipate as heat. Okay, work done against friction is always heat. Sometimes question, if they ask what is heat generated, I same as work done against friction. So you look for friction times S, friction times the displacement. Okay, and the third, MAS, you know, MAS, when the deriving kinetic energy formula also we get MAS is same as mv squared, half mv squared minus half mu squared. Increase in kinetic energy is MAS. So MAS here is gain in kinetic energy. So work done by the thrust, by the engine is always same as the gain in GPE, gain in kinetic energy, again work heat also applied, plus the first thing which is very low profile, not included in A levels, is what? Any type of energy you can convert? Sound lah. The fourth is sound, but not included lah because it's very, very small compared to the other three. So A level we ignore sound. Okay, so the equation tend to become like this. Assembly W sin theta S, friction S, MAS is an increase in GPE, heat dissipated, increase in KE. Remember here is increase in GPE. Increase GPE means final GPE minus initial GPE in bracket. You can refer to. Increase in KE is what? Final KE minus initial KE. That is increase in KE. Okay. So thrust times S is a work done. Generally, a work done by the engine, the car engine. Okay. So total work done by the thrust, by the engine is increase in GPE, heat dissipated, increase in kinetic energy. Okay. But behind GPE, remember what is realized? W sin theta S. Behind heat energy, heat dissipated, remember what is realized? Friction times S. Behind increase in kinetic energy, what realized? MAS. MAS is your increase in kinetic energy. All S here are what? All S here are distance travel along the inclined surface. Okay. So this is very important. If the car moves up the ramp with a constant velocity means changes in KE will be 0. Okay, changes in KE will be 0. Let's say a car moving up on a ramp with a constant velocity means you must know KE is 0. That means whatever work done by the engine only used to increase the GPE and heat. Okay, KE, when KE becomes 0, whenever question got constant velocity, KE is 0. Okay. This rule is applied for a horizontal surface also because this is based on conservation of energy. If the car moves in a horizontal surface, a GPE is 0. The increase in GPE will be 0. Okay, horizontal surface. That means whatever work done by the thrust is converting heat and gain in kinetic energy only. The car only gain kinetic energy and there is a heat dissipate. No such thing as GPE rises if it's flat surface. Okay. And the third, if the question says it's a smooth surface, no friction, no heat dissipated. If they say smooth surface, that means no heat dissipation. That means whatever work done by the thrust convert to GPE and kinetic energy. Okay. So this is the universal law you have to remember for inclined questions or any movement. Normally inclined equations can be used. The fourth one, if the system has no engine, it's only a trolley movement. A trolley movement is like act of nature. A trolley is moved up a ramp, it goes down. There is no such thing as thrust. The trolley don't have engine. So if there is no engine, that means the work done by the thrust is 0. The thrust is 0. No such thing as thrust. So work done, the W, work done by the thrust will be 0. So these are the four situations where each quantity most likely can be 0. Kinetic energy 0 when they say constant velocity. Heat dissipation will be 0 if they say it travel in a smooth surface, no friction. GPE gain in GPE will be 0 if it's a flat surface. If it's a flat surface. Okay, thrust will be 0 if it's not. It doesn't have engine. It's a trolley or a rod just allowed to move around. Act of nature, full of gravity only. There is no engine. Then there is no work done. No work done by the thrust. Okay, so far any questions? Okay, so this is the universal law we're going to follow. Okay, here one example. Look at the review on top. A toy car of 50 Newton moves up a slope by 2 meters from rest. Okay, let me. Sorry. Okay. Okay, this one. So let me open up this. Okay, so a toy car 50 Newton moves up a slope by 2 meters from rest with acceleration of 0.8 meter per second squared. The ramp is 30 degrees, inclined to the horizontal. Constant frictional force 30 Newton acts on the car. A constant driving force is produced by the engine. Okay, determine the work done by each of the following force. Okay, first, the frictional force exerted by the road on the car. How much is the work done by the friction force on the car? Friction force on the car is how much from this numbers given on top? Anyone? What is work done by the friction? So work done by the friction is friction time distance traveled by the car, right?
60.
F times S. Friction is how much? 30 Newton. Distance traveled by how much? 2 meter. They move up the slope by 2 meter. So frictional force is how much? 60 Newton. Okay, the frictional force is 60 Newton. Let me start. I need the whiteboard. Okay. Okay. So the inclined surface, we found that the frictional force acting down is how much? It's only 30 Newton, and it moves up for a distance of 2 meter. So work done by the friction should be 60, 30 times 2. So 60 Newton, okay, 60 Newton. But of course, it's moving up and the force is down. We have to take it as negative 60. But according to the formula formation, the work done by the thrust equals to heat here, heat is plus heat here. The direction already considered last. So you don't need to put negative here. Just 60, just put it into the formula as 60. Okay. So the work done by the friction is 60 Newton. It changed to heat energy. Okay, the work done by the friction is heat energy. Okay, next to what is the work done by the component of the weight of the car along the slope? So what is work done against the weight? So W sine theta times the distance, right? W sine theta times the distance. So of course, work done by the weight is what? The weight acting down, mg sine theta, and the thing climb up for a distance of 2 meter. Again, so work done by the weight. Okay, by the weight is equals to mg sine theta times 2. Mg sine theta times 2. Okay, so you get the answer. So in this case, how much? What is the weight of the object? It is 50 Newton. Okay, so it's 50 Newton. Mg is 50. Sine 30 is what? Sine is 30. Yeah, 30 degrees. So it's 30 degrees. Okay, 30 degrees times 2. So we found how much? Is 25 times 2 is 50. 50 joule. Yes. So this is the work done by the against weight. So this 50 joule is gain in what? Gain in increase in GPE. GPE rise by 50 joule. When the object goes up, so GPE rise by 50 joule. Okay. So that's the second one. Third, what is the resultant force of the car? Okay, the third is the resultant force. Okay, how do you find resultant force? So it's a force formation. The resultant force is what? So the car is here, mg sin theta acting down as usual. Mg sin theta is acting down. What else acting down? Friction also acting down, and of course the thrust is acting up. So the resultant force is up. The MA. We are asking for the MA. So of course the thrust minus mg sin theta, of course, minus friction will give you the MA. Okay, will give you the MA. So do you have these three forces in the explanation? What is the thrust? A toy car 50 Newton. A toy car 50 Newton moves up the slope 2 meter from rest. Acceleration. Oh, sorry. In this case, acceleration is given already. So I think you can straight away can find the resultant force. So what is the resultant force? MA, right? MA. A is 0.8. M is how much? The weight of the car is 50 Newton. So M is how much? 50 divided by the gravity, right? Sorry. I think we don't need to go for this this equation. So we straight away F equals to MA. Okay, F equals to MA. M is the weight is 50 Newton. So 50 divided by what? 9.81 will give the mass of the toy car, and multiply the acceleration, which is 0.8. Okay, now it will give you the net force. Get the net force here. Okay, so 50 times 0.8 divided by 9.81 will give you the net force. Anyone, what's the answer you got for this? Please, someone give me the answer. 50 times 0.8 times 9.81.
4.08.
Yeah, how much?
4.08.
Okay, 4.08. Okay, 4.08 Newton. So this is your net force. This is the net force. Okay, next. The driving. So the resultant force is that the driving force F of the engine. Okay, so the work done by they want the work done by the resultant force. So after you got your net force, you just multiply by the distance. Distance is how much? Distance travel is 2 meters. So this is the work done by the net force. So how much you get is 8.16 joule. 8.16 joule. Okay. So this 8.16 joule actually what is work done by the net force is same as increase in kinetic energy. The rise in kinetic energy of the car toy car is actually 8.16 joule. The increase in kinetic energy is actually what? MAS. Okay, MAS, sorry. MAS lah. MAS is the work done. Okay, the work done by the net force. Okay, the MAS. Okay, then finally, the driving force F of the engine. So what is the driving force? What is work done by the driving force of the engine? So how do you do this? Driving force given here or not? Do they give the driving force? Constant friction. The constant driving force produced. Oh, they never said what is the driving force, but you can find the driving force already one. Okay, the work done. The work done by the driving force is actually these three add up together, right? The heat energy plus increase in GP plus increase in KE, these three add up is your work done by the engine. The universal law, work done by the engine equals to gain in GPE, gain in KE, heat dissipated. Okay, increase in KE you can write in terms of MAS, mass times acceleration times distance travel. Increase in GPE you can write in terms of what? mg sine theta s the distance, the inclined distance. Heat energy can be written at the background as what? Frictional force times distance and the inclined distance. These three energy add up should be the work done by the engine. Okay. Okay. So
I have a question.
yeah, you have a question.
And the energy, there's the increase in gravitational energy and kinetic energy and heat dissipated is in terms of work, right?
In terms of work, yeah.
Okay.
Okay. Yeah.
Okay.
Okay. So come on. So I spent about I think 20 minutes explain some idea to you. Okay. Use that idea. Come on, get me the answer for this. 2 minutes for you. Okay, so the question, sorry. These are the questions. Yeah. 2 minutes for you. Crate of mass 180 kilogram. Slide from rest down a plane. Oh, this movement is from up going down. Incline at 45 degrees to the horizontal. After sliding 12 meters down, the plane it is found to have a speed of 10 meter per second, or by the time it reaches the bottom, it has gained speed of 10 meter per second. So first question, what is its kinetic energy after sliding 12 meter? This is straightforward. So of course, what is the kinetic energy is half mv square only one. So part A, I think shouldn't be a problem. So half times 180 times speed, right? 10 square. Okay. Half times 180 times 10 square. So you get 9,000 kilojoule. So 9 kilojoule, right? Not 9,000, 9 kilojoule or 9,000 joule. Okay, so A, good, not much of a problem. B, calculate the work done by the weight. Okay, what is work done by the weight? Okay, what is work done by the weight? So work done by the weight is mg sine theta times s, right? The component along the inclined surface multiplied by the distance travel along the surface. So of course it's work, right? Work done by the weight. That means work is what? Force times distance travel to the direction of the force. Yes. So mg sine theta times 12 should give you the second answer. So all of you got the second answer. Okay, I don't want to do that. Look at the question, read your question first. So second one you get by using mg sine theta times s. Okay, third, how much work has been done in overcoming friction along the plane? How much work has been done? Okay, how to do this question? How much work has been done to overcome the plane? Okay. Okay, how to find C is something you have to use the universal law, just I told you. A, B, I think fine. C. How much frictional force has been done by the plane? You should get 6 kilojoule. No need to put negative, just 6 kilojoule. You should get, if you use the, what do you call, the universal law I give you, it's just 6 kilojoule. No need to put negative, just put 6 kilojoule. How to get 6 kilojoule? That's better now. So work done by the thrust equals to gain in kinetic, gain in GPE, and work done against friction, right? So yeah, so in that formula we have work done against friction over there. Okay, work done by the thrust is how much? Anyone? Is there any thrust here?
No.
It's an act of, it's a trolley, right? Trolley. So you don't have engine to move forward, right? So work done by the thrust, you take it as what?
0.
Yeah, work done by the thrust, you take it as what? 0. It's trolley. You don't have engine. So if you don't have engine, work done by the thrust is 0. Okay, there is no work done by the thrust here. Okay, so work done by the thrust is 0 equals to gain in kinetic how much? The answer A, right? Answer A is the gain in kinetic plus second gain in potential how much? Okay, let me write the formula. So what is that? Work done by the thrust equals to what? Work done by the thrust is equals to gain in EP. Okay, gain in EP, I put gain in EP plus gain in EK plus like what? Heat. Heat. So the question asking for, actually the question never said heat, but we know this work done by the frictional law. So we're looking for this. Okay, what's this? Okay, work done by the thrust is 0 because it's a trolley. No thrust. So it's 0. Gain in EP, how much? This is gain. As I said, consider this as a gain. Okay, gain in EP. The trolley is sliding down. The trolley is sliding down, going from up. It's sliding down. The EP, gain in EP, positive or negative? We found here 9 kilojoules. We found here 9 kilojoules. So here you put positive 9 or negative 9. This is important. A small mistake in the sign, all gone. So the gain in EP, do you gain EP or you lose EP when you go down?
Lose.
Lose EP, right? So the gain in EP is actually positive 9 or negative 9?
Negative 9.
Negative 9, good. Remember, negative 9. For gain in EP is negative 9. You not gain, you actually lose. So we put here negative 9 lah. So anything sliding down, the gain in EP is always negative. If it slides up, the gain in EP is positive. Remember, important. Slides down, gain in EP is negative. Okay, plus gain in EK how much? So we found is 50 joule. Yes, 50 joule. So we put positive 15 lah. So we know kinetic energy is gain because it's going down. Okay, so negative 9 plus 15 plus heat. Heat is actually what? Heat. Okay, we put it as heat first lah. Heat is heat first. So how much the heat generated? The heat generated is okay, so you rearrange back, you get it. You get how much? Negative 6 joule, negative 6 kilojoule. So heat generated is negative 6 kilojoule. That is dissipated. Heat has been dissipated. Okay, so this is how you get the answer. This is how you recall back your universal equation. Okay, work done by the thrust is equals to gain in EP, gain in EK, heat. Okay. Okay, so that's the part C answer. How much work has been done on overcoming friction along the plane? We got negative 6 kilojoule. So to get the C answer, you must realize that work thrust is 0. Okay, because it's a trolley. Okay, D. Okay, calculate the average value of the force of friction. So how much of friction act on the system? So actually, how much the friction act on the system? Friction acting up here in this case. How much the friction? So we know heat is actually what? Frictional force multiplied by the distance traveled. We know that the distance traveled. The frictional force multiplied by the distance traveled. So is 6 kilojoule. We just put positive, just beyond the magnitude only. So the force will be what? 6 divided by the 12 meter. The 12 meter, because the distance you travel, the amount of distance the friction acted is 12 meters. So it's 0.5. So the friction is 0.5. Okay, you want to maintain here as negative 6 also can, so you put here negative 6, so you get a negative 0.5. Negative shows that it's opposite direction to the distance lah. But you don't need to put negative, just put the magnitude. It's 0.5 Newton. Okay, so this is the how you should do the working in inclined surface. Work done by the thrust is gain in EP, gain in EK, heat. Okay. Any questions about this question?
Sir.
Yeah.
Is work done scalar or vector?
Work done is always scalar.
But why C we put a negative there?
Okay, good. In this case, negative positive it means C is what's answer? Heat. Okay. Because work done is although scalar, if the force times distance travel same direction, work is positive. If the work force and distance travel in opposite direction, the work we say negative. Negative means what is the meaning of negative in work means? We did a negative work. Like let's say you are moving forward. Okay, your friction. Okay, you are let's say how may I say? Okay, car moving forward. The friction increase the car's kinetic energy or decrease the car's kinetic energy? It decreases the car's kinetic energy, right? So it gives a negative effect to the system. Negative effect means negative effect in terms of gaining kinetic energy or gaining potential energy. If any force, work done by a force, oppose gaining in mechanical energy of the system, we see it's negative work. Negative work done to the system. Friction always does negative work because friction does not increase the kinetic energy of any moving system. So it's a negative work. Okay. By putting negative doesn't mean it has direction. Okay. In work, negative means not direction. Negative means in work means, is it going to positive effect to the mechanical energy, or is going to give a negative effect to the mechanical energy? That's negative positive in work. Okay. So understand?
Then how about B? The work done, I mean, the weight causes loss in GPE, right?
Yeah.
But should I put a negative there?
Oh, okay. So for the 15, you say, the 15.
Yeah.
So you're asking, is it 15 negative 15?
Yeah, because it causes loss in potential energy.
Okay, you see, work is force time distance travel to the direction. Okay, so I need to clarify this. You see, okay. So object, if the force is here and the displacement also this direction, work is positive. If the force is here, but the displacement is this direction, the object is moving this way, but the force applied this way, the work done by this force is negative. Do you agree with this?
Yes.
Okay, so now in this inclined surface, the object moving from up, going down, right? Weight acting where? Down, right?
Yeah.
So the weight, the component of the weight is acting down. Displacement is where? Down or up?
Down.
Down. So the force and displacement same direction, right?
Oh, okay, okay.
So it should be positive. Cannot be negative. Okay.
Thank you, sir.
Okay, good.
Sir,
Yeah.
why D is not 500 Newton?
Oh, 500 Newton. Oh, okay. Made a mistake here. Yeah, good, good. Is it 500 Newton? Yeah, so 15 minus 6 kilojoule divided by the distance travel, right? So 6,000 divided by 12. Yeah, correct. Sorry, made a mistake. So D should be 500 Newton. Plus, please change. So D is 500 Newton because it's a kilojoule. Good, thanks.
Thank you.
Okay, good. Asking lots of questions. Good. Okay, keep it up. So let's imply this idea to another question now. Okay, ready for next question? Okay, so I give you 2 minutes again. Try to get the answer. Most of the time, third or fourth question, normally everyone usually get the concept. Okay, let me go to the first question. This one. Okay. Sorry, full screen. Why I control it? Okay, some clue is given at the bottom. What is the answer for this 2 minutes? Everyone, please send your answer through WhatsApp. Let me check. You can use the conservation of energy. Work done by the thrust equals to gain in GPE, gain in KE, and heat dissipated. Do this system has thrust? The system has thrust. What is the thrust of this system? 9 kilonewton. Okay, 9 kilonewton is the thrust because it was pulled up by 9 kilonewton. So that means the thrust is 9 kilonewton. Anything zero here? Gain in GPE looks positive. Is there any gain in kinetic energy? Is there any gain in kinetic energy? Okay, there is some clue there. Gain in kinetic energy. Okay. So 2 minutes for you. Come on. because we move with a constant speed, you know. Constant speed, he knew something. Constant speed means what? Zero? Gain in kinetic energy is zero. Okay. Do it as a friction? We don't know, but they're asking for heat dissipation. That means definitely as frictional. Okay. So anyone got the answer? Please try to put it into the WhatsApp. I haven't received any answer yet. Okay, good. So I got some answers. So, oh, good. Two of you saying, oh God, two of you saying A, one saying B, or many saying A. Another one is saying A. Many of you saying A. Okay, A or B? A or B? Okay. Oh, sorry. It's A or B. Okay, let me use the whiteboard to tell you. I hope you have the figures in your mind. So you see in this diagram, the work done by the thrust is 9 times 40. Actually, 9,000 times 40. 9,000 times 40 you get in Joule. Okay, that's the work done by the thrust. GP gain, how much? How much the potential energy gain? Potential energy gain is mgh. Mg, how much? What is the weight of the object? 20. 20 times h. H is 12. So GP gain is 20 times 12. mgh. Okay. So now we are finding the loss. So loss, okay, I go to the, so that means work done by the thrust, EP gain as usual, EP gain and EK gain and heat. So in this question, again, they're asking for the heat. They're asking for heat, how much? So work done by the thrust is 90 times, because the thrust up is, 9. 9. So I put as 9 because I put kilonewton because final answer is kilojoules. I don't want to convert. So 9. The distance travel along the surface here is 40, so it's going to be 40. Work done by the thrust. Again, in GPE is, we can put it W sine theta times S, or we can put as what? We can put as mgh, right? Mgh, the gain in height, the gain in height. So in this case, mg is what? Mg is found to be 20. Okay, mg is 20. Okay, so therefore it's 20 times h. Which height? Vertical height. So 12. 12. Okay, plus kinetic should be 0. This very, because constant speed, no gain in kinetic energy. So that means it's equal, actually heat, heat, yes, so heat now. So 9 times 40. So therefore, your heat you get is how much? The heat you get is negative 120. You got negative 120 kilojoule. Okay. So all of you got A is answer. Okay, so A is answer. So this is how you do the working. Okay, this is how you do the working. This is how you have to figure out. The work done by the thrust equals to gain in EP, gain in EK, heat. Okay. Work done by the thrust in this case is 9 times 40 because that's a thrust. EP is W sine theta times S, but theta not given here, but we can use mgh. What? We can use mgh. Vertical height is given here, so we can use mgh lah. Sine theta S is actually h what? Just not derivation earlier. Okay, and heat, kinetic is 0. Okay, any questions from here? You got a problem? Okay, so no problem. Okay, good. So we're going to conduct more questions about this. We done with this topic already. We done, but we're going to do questions. So you go to the past year, linking to this inclined surface. Okay, so this is the past year. Okay, let me scroll down to show you the questions. Okay, this one. November 2, 17. 1 minute for you. Come on, get me the answer. So send me the answer through WhatsApp. So work done by the thrust equals to gain in GPE, gain in kinetic, plus heat. Yeah, use that term. So car driver adjusts the pressure on a car brake so that the car travels at a constant speed down a hill from P to Q. The magnitude of the change in the car kinetic energy is Ek. The magnitude of the change in its gravitational potential energy is Ep. Which statement is correct? Okay, so I already received answers. Okay, so 2 of you saying D. Okay, the others, all of you saying D. Good. So yeah, I think quite confident this time. Everyone saying D. Okay, good. Yeah, because it moves with a constant speed, the changes in kinetic energy have to be zero. Changes in kinetic energy have to be zero. The gain in potential must be negative. Potential dropping. Okay. Work done by the thrust here must be how much? Is there any thrust here? When you're going the car moving down, do you going to apply thrust? Do you apply force forward? No force is applied forward. So in this case, the work done by the thrust of the car is zero. So no thrust applied. Okay, when you're braking. So good, D. Okay, this one. 18. This is sorry, hold on. This is which page? This is page 6. Page 6, question 18. Okay, get me the answer. 1 minute again. Come on. Put into WhatsApp. Hope everyone get the same answer like just now. A barrel of 50 kilogram. Oh, I receive answer. Good. Oh no. Oh, okay. One of you say D. Is it D? I need more answers. Come on, let's see. The barrel 50 kilograms loaded onto the back of a lorry. It was dragged up 1.6 meter high by pushing it up a smooth plank 3.4 meter. A smooth plank. The word smooth tells you what? No friction. Smooth. What is the minimum work done? What is the minimum work done? They're asking for which work? Work done by the thrust lah. You are the thrust. What? You're going to push it up. So you are the thrust lah. What is work done by the thrust here? So the question is asking for the thrust. Okay, so I receive answers D and C. One says D, one says C. Oh, now 2 of you say C. C or D? Okay, so how do you do this? So we're looking for work done by the thrust. We are looking for work done by the thrust. So we're looking for this because we are the thrust. Equals to gain in EP, gain in Ek, and heat. Okay, this is the universal based on conservation of energy. This is what happened. But we know heat is zero because it's smooth surface. They say smooth, so no heat. That means work done by the thrust is actually gain in EP and gain in Ek only. Okay. But is there a gain in Ek? Is there any kinetic energy rises? Oh, they never said anything about kinetic energy. Never said about is it accelerating what. But they said it's a minimum work. Minimum. What is the minimum work you can do? The minimum work you can do is, do you want the object to gain in kinetic energy? No need. So Ek also is like zero. EK also is 0. Like minimum work what? You just want to go little work so that it only gain potential energy only. You can do lots of work so that when the objects climb up, it will have potential plus some kinetic. Then you can do more work lah. You can do more work. Okay, but they asking, say the question asking minimum work. Minimum work
So
means, yeah.
That means that it is a smooth surface and it moves at a constant velocity up.
Yeah, constant velocity, because they said it's minimum work. Minimum work means not even gain kinetic energy. Because you just want to use a little work to push it up only. That means you only want that, you only want the potential energy to be gained. That's it. So in this case, work done by the thrust is actually same as the gain in EP only, potential only. So that means potential is what? mg h lah, the gain in height. So weight, do you know? The mg, the weight times the vertical height. That's it. So 50 times 50, yeah. So 50 times 9.81 times what? Vertical height 1.6. This is your work done by the thrust. So how much you got? 7 to 80. 780, yeah. All of you got 780, right? Okay, I think that's 780. So C should be the answer. So you get the idea. You have to think, yeah.
700.
Any problem? 780?
Wow.
Yeah, okay. So why they give 780 here? They go follow two significant figure. The lowest significant among the data provided. You see, all the data provided is 1.6. Only 2 SF, so final answer is 2 SF. So 780. That is significant to be followed. Okay. Any questions? So I hope all of you can follow. So I go to another one. Okay, another one. Okay, another one is we done this already. Okay, this one. Come on, class. 2 minutes now. I want everyone to get the same answer. Give a try. Send me your answer through WhatsApp. Come on. Hope everyone giving me the same answer. Work done by the thrust equals to gain in EK, gain in EP, heat. Sometimes some value will become 0. Read carefully. Frictionless surface, heat will be 0. Constant speed, gain in kinetic energy 0. Flat surface, gain in potential 0. If it's a trolley, no thrust, work done by the thrust is 0. Okay, are receiving your answers? Okay, this time 2 of you said B. So all of you got B as the answer. Oh, many saying B. Good. All of you saying the same answer. B, Is it B? Okay, cool. This one is, I like it. Everyone giving B, same answer. So, how to do this? So, go ahead.
Oh.
What are you looking for? What is the work done in moving a barrel distance 5 meters up the slope? So the work done by the thrust, the force, this thrust, work done by the thrust, work done by you. You are the thrust. Okay, work done by the thrust. So those who are doing this question, you should know you're looking for work done by the thrust. You are looking for work done by the thrust. So therefore, work done by the thrust, the work done by you to move the barrel up, makes the barrel to gain potential, makes the barrel to gain kinetic. Only these 3 form heat. So in this case, what are the things? 0, it's found to be 0. Heat, is it 0? Frictionless slope, so no heat generated. Okay, never rubbing is rubbing, but no, it's smooth. So we know heat is 0. Okay, kinetic, is it 0? Force barrel move with a constant speed. Constant speed. That means Kinetic energy also in this case become 0. So work done by the thrust is only gain in EP, only gain in potential energy. Gain in potential energy. So what is work done moving? So gain in potential energy. It goes up by 5 meter up. Work done is moving a barrel distance 5 meter up the slopes. 5 meter is the inclined surface line, inclined 5 meter. 5 meter incline. So vertically distance how much? So the incline is 5 meter. Incline is 5 meter. So we must use mgh, the vertical height. Mg how much? Mg is the 1000. Okay, the weight of the block 1000. And h is what? H we have to use the vertical height. If it rises diagonally 5 meter, so vertical height how much? This h is how much? The theta is 30 here. So should be 5 sine 30. 5 sine 30. So therefore you get, of course, GB is the answer. 2.5 times 10 power 3 to be the answer. So yes, good. So this is the working law. 22,500 Joule. Okay. So this is how you analyze. So inclined surface, we found work done by the thrust because they're asking for the what is work done by the air. Heat 0 because frictionless surface. EK 0 because constant speed. So EP mg vertical height, but diagonal distance given, so you have to find vertical one. So 5 sine 30. Okay. Any questions from here? Okay, no questions there. Okay, class. Time's up. Okay. So there are many questions. We spent another 1 hour, maybe about 1 hour for this topic on Monday to do revision. I want you this weekend, you can try most of the questions here in work done energy. Okay. So on Monday, if you have any problem, we discuss. If you don't have questions, I'm going to select randomly to understand. So we spend 1 hour on Monday for this topic. Then on Monday, because Monday is like 2 hours. So another 1 hour, I think I'll be starting with a new topic. Okay. Yeah.
We have the Raya.
Oh, sorry. Monday is a public holiday, right?
Yeah.
Okay. So sorry.
Monday.
Monday is a public holiday, right?
Monday and Tuesday.
Monday and Tuesday. Yeah. So then, okay. According to your timetable, how long is your holiday next week?
Only Monday and Tuesday.
So your class starts back on Wednesday, lah.
Yes.
Okay then. Okay, class. I'm sorry about that. So see you on Wednesday then. On Wednesday, okay. Those who are celebrating Raya, Selamat Hari Raya. So see you on Wednesday. Okay. So on Wednesday, first lesson, we discuss about this work energy power. Okay. Any questions?
Oh.
Okay, no questions. So see you then. Thanks.